Hello students, today we are going to learn about the multi-stage compression process. What is multi-stage compression process? Multi-stage compression, that means compression of air and gas occurs in number of cylinders in place of a single cylinder. The cylinders may be 2 or 3 or more. It is used in reciprocating compressor when high pressure air are desired. Here I am showing you the example of reciprocating air compressor. There is a piston cylinder arrangement and piston moves from TDC to BDC and BDC to TDC. At the suction stroke, when the piston moves from TDC to BDC, a cold air enters into the cylinder and this cold air gets compressed. After the compression, this cold air becomes hot because the compression process is adiabatic compression and which increases the pressure and temperature both. After the succession of the adiabatic compression, this hot air becomes more hot. So, it is very difficult to compress the hot air rather than the cold air, because when any substance at high temperature, it wants to expand, and here I am compressing, so it is very difficult to compress the hot air. With the succession of the adiabatic compression, this hot air becomes more hot, so it becomes more difficult. So it is difficult to compress a hot air rather than the cold air in case of a single cylinder reciprocating air compressor. So in case of a reciprocating air compressor, to compress hot air, more work is required to compress this hot air. So, in case of a single cylinder reciprocating air compressor, more work is required. Now, what we can do? Let's do the same thing with the another arrangement. This is a piston cylinder arrangement which containing the gas or air. This air is compressed adiabatically up to some extent. Since the compression is adiabatic, so temperature and pressure rises. If this piston cylinder arrangement is kept in an environment, then this hot air loses its heat. If this cylinder is made of some conductive material, then this hot air loses its heat to the environment, because heat always transforms from hot temperature to low temperature. And this hot air gets cooled down, and this cool air further compressed up to some extent or up to the desired pressure which we want. So, less amount of work is required to compress from this to this state. That means if we compress cold air up to this extent or up to the desired pressure, then more amount of work is required in single stage. If we are using this type of arrangement, then less amount of work is required. So this is the principle of multi-stage compression process. Now, this is the schematic diagram of the two-stage reciprocating air compression. There are two piston cylinder arrangement. This is low pressure cylinder, this is high pressure cylinder. These are pistons which moves up and down. This is motor which runs the crank. These are inlet outlet valve for the low pressure cylinder. These are inlet outlet valve for the high pressure cylinder. The valves are differential type. What is happening in this type of arrangement? In the low pressure cylinder, when the piston moves from TDC to BDC, it creates void inside the low pressure cylinder. So, because the inlet valve is differential type, so it automatically opens and fresh air enters into the cylinder. As the piston reaches to the BDC, the air enters into the cylinder. The next stroke is the compression stroke. The piston rising up and the air inside the cylinder get compressed adiabatically. So adiabatic compression increases the pressure and temperature of the air inside the cylinder. So before moving this compressed air into the high pressure cylinder, this compressed air passes through the intercooler. Intercooler is a type of heat exchanger which is made up of some conducting material. So when this high pressure compressed air from the lower pressure cylinder passes through this intercooler, it loses its heat. At one end of the intercooler it is hot, at the other end of the intercooler it becomes cold. At the same time, when the low pressure cylinder compressing the air, at the same time the high pressure cylinder sucking the cold air which is coming out from the other end of the intercooler. Because this is a steady flow process, so both the piston moves simultaneously. Now after this, the high pressure piston rising up and this pushes this air to the high pressure to the desired receiver or to the pressure vessel. You can see from these diagram here, the compressed air passes from the low pressure cylinder to the intercooler where it loses heat. At the other end it is cold, at first end it is hot. Now this cold air enters into the high pressure cylinder. Pressure cylinder, piston moves downward direction. In the high pressure cylinder, the piston moves upward direction, which compresses the cold air coming out from the intercooler and pushing this compressed air to the pressure vessel. So in two-stage compression process, we have seen the amount of work invested to compress the air at high pressure, it reduces if we are using in the single stage compression. Now we will see the working of the three-stage compression with two intercoolers. So it is a three-stage compression process. Here three cylinders are there: lower pressure cylinder, intermediate pressure cylinder and higher pressure cylinder. These are the two intercoolers. This is known as first stage intercooler. This is second stage intercooler. Now we will see what is happening in this type of arrangement. This is the PV diagram of multi-stage compression, which is three-stage compression. What is happening? Air is compressed isentropically from point 1 to 2 in low pressure cylinder. The compressed air is passed through the intercooler where it is cooled in an ideal case corresponding to its suction temperature. represented by 2, 2 dash. This represents perfect intercooling. The point 2 dash lies on the isothermal curve, which is shown by the dotted line. The air is then admitted into the intermediate pressure cylinder, where it is compressed isentropically from 2 dash to 3. Again, the air is cooled from 3 to 3 dash in the second stage intercooler before it is admitted for the final compression in the high pressure cylinder. The amount of work reduces is shown by the curve or shown by the area H2, 2-3, 3-4 in the PV diagram. This is the TS diagram of multi-stage compression. 1, 2, 2-3, 3-4 is the isentropic compression process. So, in TS plot, it is a vertical line because the entropy should be constant in adiabatic compression process. 1, 2 dash, 3 dash, 4 dash represents the isothermal process, so the temperature of all the 4 points must be equal. So it is a horizontal line in a TS plot. 2 to 2 dash is the heat rejection process. So temperature of the compressed air gets down and it is equal to the temperature of fresh air at point 1. So this is the complete TS diagram of the 3-stage compression process.